Thank you very much for having me here. And today I will talk to you about informing agent-based models of social innovation uptake. And I know that this group in particular is very keen on furthering the knowledge on how to calibrate models and how to make sure that models represent real-world cases. So I think this is why, especially for this audience, such a topic is interesting. The project I will talk to you about today is the project SMARTIES. That's a European Horizon 2020 project that just finished last year. It was an interesting project because we had 10 models to do. So 10 agent-based models of 10 different cases in 10 European cities, or of 10 European cities. And it was unusual because, it was a larger project. So we had 3 modeling teams. There was me and Van der Jager at the University of Groningen in the Netherlands. Then there was Amparo with a team of artificial intelligence experts at the University of A Coruña in Spain. And then there was Gary Polhill's team at the James Hutton Institute in Aberdeen in Scotland, in the UK. So we were looking for doing agent-based modeling together in a project where we wanted to not only do individual models, but we also wanted the models to speak to each other, or in a way, we wanted to have a setup where on the basis of our cases, we could tell a bit more than just the things about our cases. So we came up with some solutions that I think might be interesting for other researchers that work in such multidisciplinary, multi-method contexts. So here I would like to kind of provide and discuss a real life example of a complex research design. So for me, a complex research design is a design that combines more than 2 methods, that includes an agent-based model and integrating information from other sources. And that happens, as I said, in a single coherent causal mechanism. That is the goal of the agent-based model, or that mechanism that agent-based model represents. And at the same time allows us to kind of connect different models together. So I'll give you a brief introduction to the SMARTIES project, and then I'll tell you a bit about the mixed method research design we had. So what data we actually used for our modeling, and then I'll go through how we integrated that information in our agent-based models. So both in specification of the model, calibration of the model, and validation of the model. I will be using mainly 2 examples, but as I said, there were more models in that project that followed a similar logic whenever it was possible. So the SMARTIES project, this was looking into the uptake of social innovations that was related to driving a movement away from coal-based energy. So basically what we did, we had 10 cases of European cities that have introduced some sort of innovation that would make them less dependent on coal and move them towards more renewable energy sources. That topic is a very vast topic. So we had cases like Groningen that started or introduced biking. And we had cases like Stockholm, Malmö that focused on energy efficient housing. So refurbishment of existing buildings that kind of made them more energy efficient. Then we had the cases of Aberdeen and Timisoara, where we focused on fuel poverty. And then we had cases of Vitoria-Gasteiz and Barcelona, so 2 Spanish cases that were looking into superblocks, so organization of a city that would kind of make road transport more friendly to biking and pedestrians. And then we had 2 islands that were looking into, again, issues related with fuel poverty, but kind of mainly a drive away from heating in houses that was based on coal sources of energy. So in all of those cities, we were trying to build agent-based models that were based on data. And because there were 3 modeling teams and 10 models to be built, we needed some way of standardizing our approach to using data and to making model assumptions. And what we ended up was we developed a research design in each of those cases that would follow the same pattern whenever it was possible. And you will see that there were some deviations from that because of various reasons. But in principle, every single case started with desk research. So let's collect all of the information that is available on the case, independent of what type of information that is. So if there were previous articles or previous newspaper articles or previous scientific papers or books published, we would try to get those, read them, and synthesize information. If there were interviews with stakeholders published in newspapers, we would try to get that. This also involved a lot of theoretical desk research. So what theory is available to explain the phenomena that we were looking into? And based on that desk research and specifying what the innovation is in each city, we tried to come up with what the main goal of the agent-based model. So identify the target system, what should a model represent, which actual process should focus on, and then what theory should be used in the agent-based model, and then how can we use data to make it represent the case better. So in terms of theory, because we are a bunch of, or at least me and Vander, we're both psychologists and I'm also a sociologist, we used a lot of social theory to represent how people would behave in a model. Then we had in-depth interviews with various types of stakeholders to give us the data that we were missing from the desk research. Then we did quantitative surveys in an online format. So those were computer-assisted web interviews in all of the cases, and had quantitative data from that to inform the models. And then we did some workshops with stakeholders, especially policy workshops with policy stakeholders to identify counterfactual scenarios for agent-based modeling. And then we used agent-based models to actually represent the case and make the biggest contribution to our research problem. So we used agent-based modeling as a way to integrate all of the types of data that we collected with previous methods. And that was a challenging task because as you can imagine, those data came in different formats. They were from different methods. They were from different time periods, which I'll kind of come back to when talking about the agent-based model of Groningen. So that was definitely something that we needed to tackle, but I think we did quite well. I think we've managed fairly well. So this is the number of in-depth interviews, surveys, and number of workshops with stakeholders that we did for all of the cases. And as you can see, some of the cases don't have don't have surveys. And in some of the cases that had surveys, we had, I would say, conceptual problems of using survey data later on in the modeling process. So for example, in Groningen, the case that was closest to my heart because I lived in the city, the case was about, so the entire case, which is a drive to push for biking in the city. As everyone knows, the Netherlands is a biking country, but Groningen is the biking city of the biking country. So the push for biking started in late 60s. So we were facing a case that actually is a process that takes place over a 70 years period of time. So that's a very long process. And just deciding which part of that process to model, what do we focus on in a 70-year case, was demanded a lot of kind of energy and talking to stakeholders. And in the end, we decided that at one tipping point, or one of the main tipping points, was opening or closing of a park that was in the center of the city, that used to be one of the main traffic trajectories from east to west of the city. And the case was interesting because it's actually people who decided. So it was people who had a referendum, that was the first referendum in the Netherlands, and people voted whether they wanted the park to be closed for cars or to be open for cars. And this is the process that we decided to model in that case. And as you can imagine, doing a survey in 2019 did not bring us a lot of data that would be useful for modeling an event that happened in 1973. So, so even though we did the surveys and they were very helpful for the entire project, we couldn't use them to calibrate the model the way we wanted to, or to validate the model the way we wanted to. Because actually, when we did the survey, we asked people how would they vote today, so in 2019, and 95% of them said that they would keep the park closed for cars, whereas in 1973, the referendum was only 50.9%. So the social situation, people changed their mind so much that information about people in the present day was not very useful to model the case from decades ago. In other cases, as you probably are aware of the context very well, a pandemic stopped us from executing the surveys. In some other cases, we decided not to do that because of limited value of such a method now. So how did we integrate the information? So each of the models follow a similar pattern. So in each of the models, we had local community that was connected via social networks, and that community was calibrated social demographically or geosocial demographically very often to what was actually the case in that city. And we came up with HUMAT, which is a social cognitive architecture for representing agents and their decision processes. So HUMAT kind of took care of local community and social networks. Then we had social innovation that we wanted to represent. So in the case of Groningen, it was how the information about being for or against opening the park for cars or closing the park for cars spread in the community. We had policy scenarios, so counterfactual scenarios that would answer us the questions of what would have happened had something been done by the politicians, for example, or had something happened. And we had very often organizations, so city councils, newspapers, and so on and so on. So institutions that would influence how the social innovation spread. And it was all, obviously, each of the models was had specific things about the context that were important for how the model ran. So first, HUMAT. As I said, HUMAT is a social cognitive architecture that is based on Vander's previous, or loosely based on Vander's previous CONSUMAT. It is, it's one of those architectures that we have several of them now. So there was obviously CONSUMAT, there was Joshua Epstein's Agent Zero. So how do you, a piece of software that would be ready to use and be calibrated to a case that would have rules about how agents act. And agents in our case were people, so we had their decision-making process, and we had them in, so there was a cognition, or representation of cognition. And then there was a representation of the social dimension via spread of information in social networks. And HUMAT had rules for how that would happen. So each agent would decide, should I do A, B, or C, or should I be for or against something? And then they would try to convince other agents in the model to kind of have the same opinion that they have, or they would be uncertain about how they would feel and what decision they would make. So they would ask agents that they know what they should do. So it was all driven by the theory of cognitive dissonance and about kind of uncertainty about what agents would do. And then they would kind of inquire or signal in their networks and spread information that way and change each other's minds. And then we would kind of grow from bottom up the result of a referendum, for example. As I said, attitude formation in HUMAT was informed by various theories. So that was a very theoretically based architecture of kind of expected satisfaction, group norms, how other people can be persuasive to you and what that depends on, how your own experiences with the social innovation would change how you would feel about it, and so on and so on. And then that attitude would spread. Then the model calibration, and then I think this is a especially relevant topic here. So we calibrated to several aspects of a case. So we calibrated to a timeline of events with secondary data and in-depth interviews. We calibrated to the geosocial demographic characteristics of the resident population, also with secondary data. We calibrated to motives and needs of the residents with secondary data, in-depth interviews, and with the survey. Then we calibrated to social networks of residents, which again, in-depth interviews, workshops, and theory. And that was heavily based on theoretical developments of creating social networks in artificial populations. And then we calibrated to policy scenarios. So what our stakeholders, what our policy stakeholders would be interested in. For example, in the SAMSO case, so I'll give you an example. In the SAMSO case, again, case is long. There are several districts, so the case is not it's not coherent. It's not one thing. There are actually several things there to model. We decided to focus on one specific case of switching to district heating. So the case was that residents, each of them had a heating source like an oil oven or a wood oven or electricity at home that would heat their house. There was a movement of creating district heating for a given district in the city, and this is a district of the island, and this is the village of Onsberg that we decided to model, where enough of the residents would have to agree that we are switching to district heating for it to be profitable to invest in a district heating infrastructure to heat the homes there. So the actual case that we recreated with the use of secondary data and in-depth interviews was there was a lot of lobbying going on. There was a pre-construction household decisions. So before the construction of the heating network, households made the decision whether to join or not. Then the heat network was constructed. Then after the construction, houses could still change their mind and join. And then heat network came into operation. And basically that was represented in the model in a, I would say, time kind of in time steps rather than in actual dates of the model initialization, exchange of information, forming attitudes, initial household decision, and again exchanging and forming of attitudes, and so on and so on. So kind of this is how we use secondary available data plus in-depth interviews with the residents who remembered that time to reconstruct such a timeline of events to know what the model would represent. Geosocial demographic calibration, again, an insanely interesting case for me because it was very challenging. So as I said, we were in 2019, we were modeling a specific referendum from the 1970s. We had information on that referendum, and I'll talk to you about validation in a minute. But the issue was that we didn't have good information on who the people living in the 70s in Groningen were. So we went to the city's archive. So obviously data from that time is not digitalized. So we went to the city's archive and we actually scanned years of paper data. And on the basis of that, we had to reconstruct the dependencies between the characteristics of the population. So how was gender distributed? How was age distributed? How was that jointly distributed? Together with main economical activity and residency, so where and the district of where people lived. And we ended up having 936 homogeneous groups of agents that shared similar geosocial demographic profiles distributed around the city, which was really, really awesome. But as I said, really challenging. Then validation. So validation, basically use of empirical data that to see whether what's produced by the model makes any sense. Again, in the Groningen case, we had a report from a referendum, and the report from the referendum told us what was the turnout in each of the districts and what was the percentage of each of the districts that voted car-free. And in the model that we've calibrated, we could actually see the turnout on the level of the entire city, but also the turnout in each district. And as you can see, these are just snapshots of some models and their results, and they're closer. And so with the same settings, starting settings, we would have, because of the randomness in the model, we would have slightly different results. But I think all in all, the expected results were really close to what actually happened in the past, so that we could use a calibration to play with counterfactual scenarios later on. And we could do that on a district level. And as you can see, some districts were better calibrated, some districts were worse calibrated. But again, this is a question of kind of tweaking the model and having a better result on a smaller granulation, not only on the level of the entire model. So I think this is it for me. I hope I used my time well. If you have any questions, I would be happy to answer them.